Hello, Professor. Today I will walk you through my checker pieces implementation. And this project focuses on implement like two specific types of checker pieces, man and king pieces that follow authentic checkers game rules. The main objective were to create class that can accurately determine valid moves and captures, which we'll introduce later, while using the proper object-oriented design principle to eliminate code duplication. The pieces need to work on a standard A times A checkerboard where pieces can only be placed on dark square. Let me start by showing you my overall class structure, then dive deep into each implementation. So there are two packages, the checkers inside of the source and the task for main and king, these two subclass inside of the checkers package in the task directory. So first of all, let me show you the checker pieces UML diagram. So look at my UML diagram. I made several key design decisions. First, I created an abstract piece class to serve as a parent class for both man and king. This was crucial because the both pieces share common functionality, like they both need to check their position, store their color, and validate board boundaries. Without this abstraction, I would have duplicate code in both classes. The abstract piece implements the checker piece interface and provides all the common methods while leaving the specific movement logic, the can move and the can capture, as abstract methods that each subclass must implement. This design followed the template method pattern where the abstract class defines the structure but let a subclass define specific behaviors. So go back to the abstract pieces. Okay, let me walk through the abstract class constructors. It takes three parameters: the rows, sorry, wait, Control Z, Control Z, yeah. The row, column, and color, and implement several important validation. First, I check if the color is not valid. This prevents like creating pieces with undefined colors. Then I validate the position is within the A times A board boundaries. Most importantly, I validate that pieces can only be placed on dark squares. In checkers, pieces can only exist on dark squares, never on the light squares. So I use the formula row times column and the sum divided by 2 and whether equals to 1 to identify the light squares and reject them. And so this class stores three protected fields. Yeah, those three. They're protected so that the subclasses can access them directly for better performance. And I provide getter methods that simply return this value to fulfill the interface contract. And I have two more helper function is within board for boundary validation and is dark square for dark square logic that both subclasses can use to eliminate duplicate code. And here we have our main classes. So the key characteristic of this class is that man can only move forward. The can move method determine if a man can move to a given destination. But like I want to be more specific about forward meaning. This depends on the coordinate system. First, I validate the destination is within the board bounds using our helper methods. Yeah, and the specification stores rows decrease from top to bottom, meaning row 0 is at the bottom and the row 7 is at the top. Black pieces start at the top and move toward lower row numbers, so the direction is -1. White pieces start at the bottom and move toward higher row numbers, so the direction is +1. Then I verify the move is exactly one row in the correct direction and exactly one column diagonally. This ensures proper diagonal forward movement. And for the can capture method, like which handles jumping over opponent pieces, So first, I verify the target piece exists and is the opposite color. We cannot capture knob pieces or our own pieces. Then I calculate the position difference to determine if the opponent is exactly one diagonal square away in the forward direction. If the capture is valid, I calculate where the piece would land after jumping. That is the opponent's position plus one more step in the same direction. Finally, I verify the landing square is within the board boundaries. And the king class is like represents promoted pieces that have gained additional movement abilities. The key difference is that king can move in any diagonal direction. So can move again. The king's can move method is simpler than the man's because it doesn't need directional restriction. I first check if the destination is within board bounds. Then I simply verify the move is exactly one square diagonally in any direction, forward, backward, or sideways. No direction variable needed. And can capture again. The can capture method for king follows similar logic but allows capturing in any diagonal direction. So I first verify the target piece exists and is the opposite color. And I calculate the position differences to check if the opponent is one diagonal square away. Unlike the man, I checked for diagonal adjacency in any direction, not just forward. I used the integer dot signum to calculate the landing position. This worked for any direction because signum returns like -1, 0, or 1 based on the sign of the difference. Finally, I verify the landing square is within the board boundaries. And my testing approach covers several critical areas. I test valid moves for both piece types in all allowed direction and invalid moves that should um, that should be rejected. And for this class, I test capture scenario including successful capture and failed capture when pieces are the same color or when landing squares are off the board. I also test constructor validation intensively, null value, out of bounds position, and the dark square requirement. So it's pretty clear pseudo's naming. Okay, so in conclusion, I still met some challenges. So one of the biggest challenge I faced was understanding the coordinate system correctly. Initially, I implemented the movement direction backward because I misinterpreted rows decreasing number from top to bottom. I thought like the black piece should move in the positive row direction, but actually they move in the um, negative direction because they start at higher row numbers. And one more challenge is that, yeah, so this illegal argument exception. I solved this by carefully rereading the specification and tracing through expected movement step by step. Another challenge was balancing the dark square validation to enforce game rules while allowing testing flexibility. These challenges taught me the importance of carefully analyzing requirements and thoroughly testing different scenarios. Thank you for listening.